Microsoft Peering Overview. Welcome to our deep dive into ExpressRoute Microsoft Peering. This is where things get really exciting because we're going to connect your on-premises network directly to Microsoft's cloud services like Office 365, Azure PaaS services, and Dynamics 365. Unlike private peering, which uses private IP addresses for Azure IaaS resources, Microsoft Peering operates with public IP addresses to access Microsoft's cloud services. This gives you optimized, predictable routing to services like Exchange Online, SharePoint, and Teams. What makes this powerful is that your Office 365 traffic no longer goes over the unpredictable internet. Instead, it flows through your dedicated ExpressRoute circuit with guaranteed bandwidth and consistent performance. Today we'll build a complete Microsoft Peering implementation, including the critical route filtering that controls exactly which Microsoft services you can access through ExpressRoute. This level of control is essential for security and cost management. Microsoft Peering Architecture. Let me walk you through this architecture diagram because Microsoft Peering has some unique characteristics that are different from private peering. Notice that we are using public IP addresses throughout this design. Your organization needs to own and validate these public IP prefixes. You can't just use any random public IPs. Microsoft requires proof of ownership through routing registries like ARIN, RIPE, or APNIC. The route filter is a critical component that you do not see in private peering. This controls which Microsoft services are accessible through your ExpressRoute circuit. Without proper route filtering, you might receive thousands of Microsoft service routes, which can overwhelm your on-premises routers. BGP communities are the magic here. Microsoft tags their service prefixes with specific community values like 12,076 to 5,010 for Exchange Online. Your route filter uses these communities to selectively allow or deny access to specific services. The beauty of this design is that your users get optimized paths to Microsoft services while you maintain complete control over which services are accessible and how traffic flows. Microsoft Peering has significantly more prerequisites than private peering, and getting these wrong will block your implementation. Let me walk you through each requirement. First, you'll need owned public IP prefixes. These must be registered to your organization in a routing registry. You cannot use borrowed or leased IP space, as Microsoft validates ownership as part of the peering approval process. Your AS number must also be registered to your organization. While private peering allows private ASNs, Microsoft Peering requires a public ASN that's properly documented in routing registries. The letter of authorization from your IP registry is crucial. This document proves that you're authorized to announce these IP prefixes. Microsoft's validation team will review this before approving your peering configuration. The premium SKU is required because Microsoft Peering involves global routing and access to services across all Azure regions. The standard SKU simply does not support these advanced routing features. Don't underestimate the validation timeline. Microsoft's review process can take 3 to 5 business days, and any missing documentation will reset the clock. Foundation setup. We're starting with the same foundation as any ExpressRoute implementation: resource group and circuit creation. However, notice the key differences for Microsoft Peering. I'm using West US 2 as our location, and the premium SKU is non-negotiable for Microsoft Peering. The bandwidth choice of 2 Gbps reflects that Microsoft Peering often carries more diverse traffic than private peering. The provider choice matters more for Microsoft Peering because not all providers support it equally well. Some have better peering relationships with Microsoft's global network, which can affect performance to services like Office 365. Unlimited Data SKU family is often more cost-effective for Microsoft Peering because cloud service usage can be unpredictable. Office 365 traffic patterns are very different from traditional data center workloads. The tags here are crucial for tracking costs. Microsoft Peering can be expensive if not managed properly, So good tagging helps with cost allocation and chargeback to different business units. Public IP validation process. This is where Microsoft peering gets complex, and frankly, where most implementations get delayed. The public IP validation process is rigorous, and Microsoft takes it seriously for security reasons. When you show the circuit details, you'll see validation status fields that track Microsoft's review of your documentation. The circuit starts in a not validated state for Microsoft peering until this process completes. You'll need to open a support case with Microsoft and provide your letter of authorization, registry documentation, and proof that your organization owns the ASN. The validation team will verify everything against public databases. Pro tip: start this validation process early, even before your circuit is provisioned. You can submit the documentation as soon as you create the circuit, which parallelizes the timelines. I've seen organizations wait weeks because they didn't understand this requirement. Don't let poor planning delay your Microsoft peering implementation. The validation is mandatory and can't be bypassed. Microsoft peering configuration. Now we're configuring the actual Microsoft peering session. This looks similar to private peering, but the parameters have very different meanings and requirements. The peer ASN must be your organization's public ASN, not a private ASN like we used in private peering. This ASN must be registered to your organization in a routing registry. Notice that we're advertising public IP prefixes that your organization owns. These /30 subnets for the BGP sessions must also come from your own IP space. You can't use random public IPs. The customer ASN and routing registry name are part of Microsoft's validation process. They'll verify that your ASN is properly registered and that you're authorized to use it. VLAN ID 200 is just a convention. I use different VLAN IDs for different peering types to keep traffic separated. If you also have private peering, it might use VLAN 100. Once this command succeeds, Microsoft's validation team will review your configuration and documentation. The peering won't become active until they approve everything. Root filters and BGP communities. Root filters are absolutely critical for Microsoft peering. They're your primary tool for controlling costs and security. Without proper root filtering, you'll receive thousands of Microsoft service routes that can overwhelm your network. BGP communities are how Microsoft tags their services. Each major service has a unique community value. For example, 12,076 to 5,010 for Exchange Online, 12,076 to 5,020 for SharePoint, 12,076 to 5,030 for Teams. These communities let you granularly control access. The root filter creation is straightforward, but the real complexity is in understanding which communities you need. Microsoft publishes a comprehensive list, but it changes as they add new services. I always recommend starting with a restrictive approach. Only allow the specific services you need initially. You can always add more communities later, but removing access can disrupt user workflows. The root filter rules use an allow action, which means any communities not explicitly listed will be blocked. This default deny approach is much more secure than trying to block unwanted services. Service-specific filtering. This slide shows you how to build comprehensive root filters for different Microsoft services. The power of BGP communities really shines here because you can create very granular access policies. Notice how I'm creating separate rules for each service category. This granular approach makes troubleshooting much easier. If users can't access SharePoint but Exchange works fine, you immediately know to check the SharePoint community. The community values follow Microsoft's numbering scheme. 5000 series for Office 365 services, 5100 for Azure services, 5200 for Dynamics 365. Understanding this pattern helps you organize your root filters logically. Azure Services Community Value 12076, 5100 is broad and includes many POS services like storage, SQL database, and Cosmos DB. You might want to be selective here depending on your security requirements. Dynamics 365 Community Value 12076-5200 covers the entire Dynamics suite. If you only use specific Dynamics applications, you might want to research more specific communities for tighter control. Remember that applying the root filter to the peering is the final step that makes these rules active. Until you apply the filter, all Microsoft roots are blocked by default. Connection testing and verification. Testing Microsoft peering requires a different approach than private peering because we're dealing with public services and BGP communities rather than simple IP connectivity. The first verification step is checking that your Microsoft peering session is established and that you're receiving the expected routes. The BGP session status should show connected, just like private peering. But the real test is in the route advertisements. You should see routes for Microsoft services appearing in your on-premises routing tables, tagged with the appropriate BGP communities. If you're not seeing these routes, check your route filter configuration. Testing actual service connectivity is crucial. Try accessing Office 365 services from your on-premises network and verify that traffic is flowing through ExpressRoute rather than the Internet. Tools like TracerRoute can help confirm the path. The routing weight parameter becomes important if you have multiple Internet connections. You want to ensure that Microsoft service traffic prefers the ExpressRoute path over Internet paths for optimal performance and security. Office 365 connectivity validation is where the rubber meets the road for Microsoft peering. This is what your users will actually experience, making thorough testing essential. Microsoft provides specific tools for testing Office 365 connectivity over ExpressRoute. The Office 365 network connectivity test can verify that your traffic is taking the optimal path to Microsoft's services. Network trace analysis becomes critical here. Capture traffic from user workstations, and verify that Office 365 requests are being routed through your ExpressRoute circuit rather than the Internet. Pay special attention to authentication flows. Office 365 authentication traffic might take different paths than application data, and some authentication services might not be available over ExpressRoute. User experience testing should cover all the Office 365 services your organization uses, including not just email, but also SharePoint, Teams, OneDrive, and any other applications. Different services might behave differently over ExpressRoute. Do not forget about mobile devices and remote users. They will still use Internet paths to Office 365. So make sure your ExpressRoute implementation does not negatively impact users who are not on your corporate network. Now let's dive into how Microsoft peering opens up access to Azure Platform as a Service offerings. This is where Microsoft peering really shines beyond just Office 365 connectivity. The BGP community 12076 to 5100 covers a vast array of Azure services, including storage accounts, SQL databases, Cosmos DB, Key Vault, and many others. This means your on-premises applications can access these services through your dedicated ExpressRoute circuit instead of the public Internet. The key benefit here is the improvement in performance and security. Your applications get predictable, low-latency access to Azure PaaS services, and the traffic never leaves Microsoft's network backbone. The service endpoints integration is particularly clever. When you configure service endpoints on your Azure virtual networks, combined with Microsoft peering, you get a secure tunnel from on-premises directly to specific Azure services. Storage access patterns are transformed with this setup. Large data transfers, backup operations, and real-time analytics workloads all benefit from the dedicated bandwidth and consistent performance of ExpressRoute. Performance optimization strategies. Performance optimization for Microsoft peering requires a different approach than private peering because you are dealing with Microsoft's global service infrastructure rather than your own Azure VMS. The performance metrics shown here represent real-world expectations for different Microsoft services over ExpressRoute. Office 365 typically sees 20 to 40% performance improvement, while Azure Storage can see even bigger gains for large transfers. Connection pooling becomes critical for Microsoft services. Unlike traditional applications, Office 365 and Azure PaaS services benefit greatly from persistent connections and connection reuse patterns. Geographic proximity to Microsoft's edge locations makes a huge difference. Choose your ExpressRoute peering location carefully. It should be as close as possible to both your users and Microsoft's major presence points. Bandwidth planning for Microsoft peering is tricky because usage patterns are less predictable than traditional data center traffic. Office 365 usage spikes during business hours, while backup and analytics jobs might run overnight. QoS policies should prioritize real-time services like Teams and Skype for business over bulk data transfers like OneDrive sync or SharePoint uploads. Security and compliance framework. Security with Microsoft peering requires a layered approach because you are essentially extending your network perimeter to include Microsoft's cloud services. The conditional access policies integration is powerful. You can configure Azure AD to treat ExpressRoute traffic differently than Internet traffic. This enables scenarios like requiring less stringent authentication for users coming through ExpressRoute. DLP policies become more effective when you can distinguish between ExpressRoute and Internet paths. You might allow certain sensitive operations only when users are connected through ExpressRoute. Compliance frameworks like HIPAA, PCI-DSS, and SOX often have specific requirements about data transmission paths. ExpressRoute Microsoft peering can help meet these requirements by providing a documented, auditable path for sensitive data. The security monitoring integration with Azure Sentinel and Microsoft 365 Defender provides enhanced visibility when traffic flows through ExpressRoute. You get better correlation between network events and security incidents. Advanced monitoring and analytics. Monitoring Microsoft peering effectively requires understanding both the network layer and the application layer performance. Traditional network monitoring tools only tell part of the story. The Network Performance Monitor integration with Azure Monitor provides end-to-end visibility from your on-premises network through ExpressRoute to Microsoft services. This correlation is invaluable for troubleshooting performance issues. Office 365 Service Health integration with your monitoring systems helps you distinguish between ExpressRoute issues and broader Microsoft service problems. There's nothing worse than troubleshooting your network when the issue is actually with Microsoft's service. User experience monitoring becomes critical because Microsoft peering affects how your users interact with cloud services. Tools like synthetic transactions can continuously test the user experience through ExpressRoute. The BGP route monitoring is essential. You want alerts when you stop receiving routes for specific Microsoft services. If SharePoint routes disappear, you need to know immediately before users start complaining. Troubleshooting Microsoft peering. Troubleshooting Microsoft peering is more complex than private peering because you are dealing with Microsoft's global infrastructure and services that you do not control. The troubleshooting flow I have developed over years of Microsoft peering implementations starts with the basics, BGP sessions and route advertisements, and then moves to service-specific testing. Route filter misconfigurations are the most common issue I see. Users cannot access a specific service, and it turns out the BGP community for that service is not included in the route filter. Always check the route filter first. Authentication flow issues are tricky because some Office 365 authentication still goes over the internet by design. This is normal, but it confuses people who expect everything to go through ExpressRoute. Performance issues often stem from suboptimal routing on Microsoft's side. Unlike private peering where you control both ends, Microsoft peering requires working with Microsoft support to optimize routing through their global network. The ExpressRoute troubleshooting tools in the Azure portal are invaluable. They can test connectivity to specific Microsoft services and show you exactly where traffic is flowing. Microsoft peering creates interesting opportunities for hybrid identity scenarios that go beyond just network connectivity. The integration with Azure Active Directory becomes much more sophisticated. Named locations in Azure AD can be configured to recognize traffic coming through ExpressRoute versus the Internet. This enables risk-based authentication policies that treat ExpressRoute users as trusted locations. The Azure AD Connect integration performs much better over ExpressRoute, especially for large organizations with frequent directory synchronization requirements. Password hash sync, pass-through authentication, and federation traffic all benefit. Certificate-based authentication scenarios work particularly well with ExpressRoute because the dedicated connectivity provides predictable performance for peak AI operations. Multi-factor authentication policies can be optimized based on connection type. Users connecting through ExpressRoute might require fewer authentication factors than those coming from the Internet. The key insight here is that ExpressRoute enables identity policies that weren't possible with Internet-only connectivity. You can make security decisions based on the network path, not just the user identity. Advanced Route Management. Advanced route management is where Microsoft peering gets really sophisticated. You're not just accepting all Microsoft routes, you're actively managing which services are accessible and how traffic flows. Route filter strategies should align with your organization's cloud adoption roadmap. Start restrictive and gradually add services as they're approved and tested. This approach prevents users from accidentally accessing unauthorized services. The regional preference configuration is powerful but underutilized. You can influence which Microsoft regions your traffic prefers, which is important for data residency and performance requirements. BGP community manipulation allows for sophisticated traffic engineering. You can prepend AS paths or adjust local preferences to control how traffic flows through multiple ExpressRoute circuits or Internet connections. Route aggregation and summarization become important as you scale up your Microsoft peering implementation. Too many specific routes can overwhelm older on-premises routers. The automation aspect is crucial for enterprise deployments. You want infrastructure as code approaches for managing route filters and BGP policies, not manual Azure portal clicking. Implementation success and next steps. Congratulations! You've successfully implemented Microsoft peering for ExpressRoute. This is a sophisticated achievement that provides your organization with optimized, secure access to Microsoft's cloud services. Let's recap what we've accomplished. We've created a premium ExpressRoute circuit, navigated Microsoft's validation process, configured BGP communities for service access, and established monitoring and security controls. Your users now have predictable, high-performance access to Office 365, Azure PaaS services, and Dynamics 365 through your dedicated ExpressRoute circuit. This foundation supports advanced hybrid cloud scenarios. The monitoring and troubleshooting practices we've implemented will help you maintain optimal performance and quickly resolve issues. Remember that Microsoft peering requires ongoing management. It's not a set it and forget it configuration. For next steps, consider implementing private peering on the same circuit for comprehensive hybrid connectivity, exploring advanced security features like conditional access based on network location, and optimizing your route filters as your cloud adoption evolves. Most importantly, you now understand the principles and practices for managing Microsoft peering at enterprise scale. This knowledge enables more advanced scenarios like multi-region deployments and sophisticated traffic engineering.